Given a string word and an integer number friends. In each round, split word into number friends non-empty contiguous parts. Each distinct split appears once, and every part from every split is placed in a box. The answer is the lexicographically largest string found in that box. Example 1, word is DBCA with number friends 2. 3 splits, D with BCA, DB with CA, and DBC with A. The box holds D, BCA, DB, CA, DBC, and A. The lexicographically largest piece is DBC. Example 2, word is 4 G letters with number friends 4. Only one split exists, for single G parts, so the answer is G. The game requires us to split a word into non-empty contiguous pieces for our friends, placing every fragment from every distinct split into a giant box. Our goal is to sift through that box and pull out the lexicographically largest piece. Instead of simulating every split, think about the box abstractly. Every piece inside it is just a contiguous substring of the original word. So our goal becomes finding the lexicographically largest contiguous substring. But we cannot take the entire word as our substring. With exactly 3 friends, and each friend needing at least one non-empty piece, we must save enough characters at the tail for the remaining friends. That puts a hard cap on how long any candidate substring can be. This gives us a strict upper bound on every candidate slice. If the word length is n, and each of the other friends needs at least one character, no start index may take more than n-, number friends -1, characters. That cap is not a promise that the final answer is that long. Alphabetically, a longer string is always greater than or equal to its shorter prefix. So from any starting index, extend while allowed, take min of the tail room and the cap. Finally, we linearly scan every start index. From each index I, take the longest allowed substring with length min, n-I, n- number friends +1. Compare that candidate against the best string seen so far and keep the lexicographically largest. That single pass finds the optimal piece. In this example, the winning piece DBC hits the full cap of 3 from index 0, easy to mistake that for a rule. We need a second example where the cap is still 3, but the best box piece is shorter. Watch this edge case on screen. The cap is an upper bound, not a required length. From index 1 we can take 3 characters, a and n. From index 2 the word ends early, leaving only nn. Because n beats a, the shorter tail piece wins the whole box. First, an immediate guard. If number friends equals 1, no split happens, the whole word goes in the box, so return it and skip the scan. For the general case, set max_len to n-, number friends -1, here, 3. That caps each candidate slice. Start max_string empty, then loop every start index. At index 0, the slice runs to min of max_len and the tail room, 3 characters, dbc. As the first candidate, it becomes max_string. At index 1, our scan pointer steps forward. The capped slice is BCA, still 3 characters. Alphabetically it loses to DBC, so max_string stays locked. At index 2, the window hits the string edge and shrinks. Only CA remains. It loses the comparison, and our champion stays DBC. At the last start index, only A remains. It loses 2, and the scan finishes. Every start index checked under the cap, we return the best lex piece, DBC. Let n be the length of word, and cap be n minus open parenthesis number friends minus 1 close parenthesis. Time is big O of n times cap in the worst case. Each start index builds a capped slice and compares it to the best so far. Because cap is at most n, that is big O of n squared when cap grows with n, space is big O of 1 auxiliary, only the loop index and trackers, the returned best string is output. Function answer string takes word and number friends. If number friends equals 1, take the early exit. Return the whole word unchanged. Set n to the length of word. Max len is n minus open parenthesis number friends minus 1 close parenthesis. Start max string empty. Loop I across every start index from 0 through n minus 1. Take is the smaller of max len and the tail room n minus I. Candidate is the substring of words starting at I with length take. If candidate beats max string lexicographically, update the best. Set max string to candidate. Return max string.